Okay, today's lesson is on solving equations. At the top of your lesson sheet, you have the different properties of equality. And as you look at this, you can see that if we have A equals to B, then if we were to add C, meaning some number, to A, and as long as we add the same C to B, then the sides would still be equal. If A is already equal to B, meaning if both sides are already equal to each other, then whatever we add to one side, we would have to add to the other side in order to keep the same equality. Same thing with subtraction. Same thing with multiplication and division. Basically, all this is saying is whatever you do to one side of the equal sign, you have to do to the other side of the equal sign. That's all that it's saying, okay? So we're going to start out real easy here, and I would really recommend that however I do it up here on the board that you do the exact same thing on your paper. Okay, so looking at the first one, x plus 5 equals 12. All right, so sometimes it's helpful if you draw a line down through the center so you see the equal sign. So you see that there are two sides to this equation. On the left side, you can see what is being done to the x. You can see that it's plus 5 that's being added to that side. So the whole point in solving equations, and I'm starting real basic because this is going to get really involved, so I'm probably already saying some things that you know, and that's fine. You want to get the variable by itself. Your end result needs to be x equals and then a number, or L equals and then a number, or T equals and then a number. So your variable by itself, that's the goal. So if you look at this side right here and you say, okay, well, what is happening to my x? Well, there's a 5 that's being added to that x. If I were to subtract 5 from 5, then I would have x by itself, and that would be good. But if I'm going to subtract 5 here, I have to come and do the same thing to this side of the equal sign in order to be fair. What you do to one side, you do to the other. So the way I want you to write that is I want you to write it underneath like this. Okay, and then 5 minus 5, a positive 5 and a minus 5 is just 0. So you're left with x equals, and then 12 minus 5 would be 7. So that one would be done. X is 7. And if you want to check yourself, you take your 7 and you substitute it in up here, which is what you were doing yesterday in your homework, is you were given a solution and you were supposed to check and see if it was a correct solution. So if you plug 7 in back up there, 7 plus 5, it is 12, so you know you did it right. Okay? All right, let's look at the next one. Letter B. We have x minus 4. We want to get rid of that minus 4. We want to undo. That's what you're trying to do. You look at what's happening and you do the opposite. I see a subtract 4, so I'm going to do what? Add 4. So put plus 4 here. Well, if I do that to this side, I have to come to the other side and do it. So a minus 4 and a plus 4 makes 0. You don't write 0. You just bring down your x equals, and a negative 10 plus 4 is a negative 6. And you're done. Excuse me. Okay, letter C. What is happening to the x? What do you see?
It's added 4.
It's a plus 4. So how are we going to undo the plus 4? Subtract 4 on both sides of the equal sign. So x equals, what's 2 minus 4? Negative 2. Very good. Okay, I'm going to speed up a little bit right here. Now, look here. Look at 4x. What is happening to the x? It's being multiplied by 4. What is the inverse of multiplication? Division. So we are going to divide by 4. But listen, write it like a fraction. Fractions mean division. So I want you to write it this way. Divide by 4, then come to the other side, divide by 4. Well, 4 divided by 4 is not 0. It's 1, but that's good. That's what we want. We want to have 1x or just x. We don't put the 1 in front. And 20 divided by 4 is 5. Okay, I want you to be showing that step that you're doing. Now when you get to this one over here, we have 2/3 times x. So usually kids are like, well, that's multiplication, 2/3 times x, so I should be dividing. Well, you are. You should divide by 2/3. However, when we divide by fractions, remember we do keep, change, flip? So you're really, instead of dividing, you're really multiplying by whatever it would be if it was flipped around, which is 3 over 2. Now, if I'm going to multiply this side by 3 over 2, I have to come over here and multiply this side by 3 over 2. Make sure you're writing all of this down. I don't want to have to call any names out for not paying attention since we are recording, so I'd appreciate it if everyone would just stay focused. All right, so now look what happens here. On this side, 3 times 2 is 6, and 3 times 2 is 6, and 6 divided by 6 is just 1, right? So that's why we do that, is because that'll leave us with just x equals. Now, on this side, put a 1 underneath this negative 18, and do some simplifying if you can. Do you notice the 2 and the 18 can simplify? 2 can go into itself once, and 2 can go into 18 9 times. But there is a negative there, so don't leave off that negative. Now multiply straight across, and negative 9 times 3 is negative 27 over 1, which we don't need to put over 1. So negative 27. Okay, look over here. What's happening to the x in letter F here? What does that say? That says x divided by 7. What is the opposite of dividing by 7? Multiplying by 7. So we're going to multiply by 7 here. Or if it helps you, write it 7 over 1 if you want. 7 and 7 over 1 are the same thing. And then multiply by 7 over here. So 7 and 7 simplify. That's how we're left with just x equals. And 3 times 7 is 21. Okay, those are the super easy problems right there. So hopefully you followed okay with that. Are there any questions with that section? Okay. All right. Part 2 says, consider the expression 2x plus 7. Without your calculator, determine the value of this expression for x equal to 10. Well, this is something we've already done. Okay, if x is 10, 2x, that means 2 times x, or 2 times 10, right? Plus 7. That's what you should be writing down. Well, 2 times 10 is 20. So 20 plus 7 is 27. Okay, then at part B says, well, when determining this value, what operation did you perform first? What did we do first?
2 times 10.
We did multiplication. We did the 2 times 10, so multiplication. And then what did we do second? Addition. We did addition. Okay? Now, solve this equation right here. Okay, well, think about inverses in what you're doing. Okay, so in order to solve this equation, this is going to be a 2-step equation. We've got 2 steps to do here. So the first thing you're actually going to do when you're working backwards, see, because we're working backwards to figure out x, is you're going to do your addition and subtraction first. Maybe you make a note here. Addition or subtraction first, then multiplication or division. That's going to come next. So if you look at this equation that we have here, and we have our equal sign right here, if we have to undo any addition or subtraction first, do you see that plus 7?
Yeah.
We need to get rid of that first. How do we do that? Subtract 7 on both sides. Okay, so we're left with 2x equals 15 minus 7 is 18. I mean, sorry, not 18, 8. Okay, and then we can get rid of that 2 because now we have multiplication left. Okay, and how do we do that? Divide by 2. So x equals 4. Okay, so you have to undo your addition and subtraction first, then your multiplication and division. So let's look at this next example right here. So what do you suppose that we should do first here? Add 1. Very good. We get rid of addition or subtraction first. We see a minus 1, so we're going to add 1 to both sides. So we have 6x equals what? 13. Now we can get rid of any multiplication or division. Well, we see multiplication, so we're going to do what? Division. We're going to divide by that number in front so that we get 1 over 1. And that means we have to do the same thing over here. So x equals, now, don't leave it that way. You can write it as a mixed number. How many 6s go into 13? 2 with 1 left over, right? 2 and 1/6. Okay, let's look at letter B here. What do you suppose we would get rid of first?
7.
That plus 7. How? Subtract 7. It is a plus 7, so we subtract 7. Bring down that x divided by 4 equals 13 minus 7 is 6. Now, that says x divided by 4, so what are we going to do? Multiply by 4. What you do to one side, you do to the other side. These 4s simplify to 1, so we're left with x equals 24. Okay, are you guys doing okay so far?
Yes.
Okay, look at this one. What do we get rid of first? How? Yes, good. Subtract. 25 on both sides. So 2x equals what's 7 minus 25?
Negative 18.
Good. Negative 18. How do we get rid of that 2 times x? No, that is multiplication. So we're going to divide by the number that we want to get rid of. So we're left with x equals negative 9. Okay, flip your page over. Okay, on letter G. What do you suppose we get rid of first?
The subtraction.
The subtract 2.2. So we're going to add 2.2 to both sides. Now be careful because you're adding a whole number with a decimal. So we have 5x equals what? 6.2. Then we're going to get rid of the 5 by dividing. So we're left with x equals, now go out to the side and do 6.2 divided by 5. All right, what are we getting? 1.24. Good. All right, letter H. Some people don't like their x to be on the right-hand side. So if you prefer to write this as 8 minus 0.1x and then put the equals 3 on the other side, that's fine. All right, now be very careful here. What do you suppose that we should do first?
Subtract 8.
Good. Well, it is subtract 8. Some kids want to add 8 because they see that subtraction sign. But that subtraction sign really goes with this 0.1. The sign that goes with the 8 is in front of it. If you don't see a sign in front, then it's a positive 8. So we get rid of that positive 8 by subtracting 8. So come to the other side and do the same thing. So we have negative 0.1x equals, what's 3 minus 8? Negative 5. Then we're going to do what? Divide by negative 0.1. So a negative divided by a negative is going to be a positive. And what would 0.1 divided by 5 be? 50. Good. All right. This one, the 3's kind of, well, I think I wrote it in there, so it should be a little easier for you to see. All right, so what do you suppose we get rid of first here? The plus 2. How? Subtract 2. So we have a negative 5/3 x equals what? Negative 20. Good. All right, now, how did I say we get rid of a fraction here that's multiplied to a variable? Well, we're going to multiply by what? 3/5, but you got to keep that negative. You multiply by exactly the same sign that you had. See, that way, look here, we'll get a positive 15 over a positive 15, which is just 1. Check yourself. If when you multiply the numerators and denominators and then divide that, you don't get positive 1, then you haven't done something right. Okay, so that'll give us positive 1 because all of this simplifies, doesn't it, to 1. So you're left with x equals, that's really a negative 20 over 1. Now that 5 and 20 can simplify. 5 goes into itself once and into 20 4 times. And don't forget that negative that's there with the 20. So we're left with, whoops, we're left with Negative 4 times negative 3, which is 12. Good. Very good. All right. So for this next section, we have to fill in the blanks, or excuse me, we have to write an equation, and then we have to solve it. Okay? So this one says 5 times a number increased by 7 is 37. 5 times a number, how do we write that? 5x increased by 7 is 37. There you go. All right, solve that. On your own, based on what we just did, solve that. Okay? Raise your hand if you've got an answer. Brady? X equals 6. Good. You should have subtracted 7. You would have gotten 5x equals 30. And then divide by 5, and you get x equals 6. Very good. Okay, letter B. The difference between twice a number and 3 is 2. How do you write that?
2x times 2.
There you go. All right, solve that one. Okay, who's got an answer for me?
I got the
Okay, Michael? Matthew? Sorry.
x equals 2.5.
X equals 2.5. Very good. Okay, let's look at the letter C. 10 less than 2/3 of a number is negative 4. How do we write that? 10 less than 2/3 of a number equals negative 4. 2/3 x minus 10 equals negative 4. Okay, go ahead and solve that. You should be getting rather good and quick at these two-step equations. If you have any questions, you need to be raising your hand and letting me know. Did we get 9? I didn't simplify right here. That would have been smarter, but I was kind of running out of room. Okay, let's look at it says exercise number 1. Fill in the blanks of each of the following lines with the real number property that justifies this particular step. So look at what we have here. We have this, and then now it's said equal to that. What property would that be? The commutative. Notice that the 4x is switched here with the 7y. So that's the commutative property. Good. Okay, what about the next one? That is the distributive property. Okay, now this part is very important. This is going to lead us into another type of solving equations, so I really need you to pay close attention here. Okay, letter A. This is combining like terms, which is what we did a little bit in the last unit. What can we combine here?
5x.
Okay, what does that become? 11x, and then plus what? 17y. Good. Let's go to letter B. 3x and 1x, 4x, positive 7, negative 5, plus 2. Letter C. 1.4x, 3.2x, 4.6x, and then positive 2.y and a negative 1.5y. What type? But what sign goes in there? It's positive because 2.9 is bigger. Good. All right, over here, negative 4a and positive 9a, 5a. Put them in alphabetical order. A comes first. Then we have 3b and negative 10b, negative 7b. All right, letter H, negative 7x and 3x. Negative 4x. Keep the sign of the bigger number. 4 and negative 10. Negative 6. Very good. All right. 12a and negative 6a. 6a. 2b and negative 8b. Negative 6b. Good. Now this bottom is kind of messed up a little bit down here. We don't need to do anything with this calculator or this line over here. But we are going to solve this equation. What do you suppose we do first here? Yes, look on the individual sides first. If on one side of the equal sign you have like terms, you should combine them first. So 2x and 3x is 5x. 3 and 4 is plus 7 equals 17. Now we're going to solve like what we were just working on, right? So what would we do first? Subtract that 7. We see a plus 7, we minus 7. So 5x equals 10. Then we are going to divide by 5. So x equals 2. Okay, so do you see the extra step there? You have to combine like terms. Okay, that big problem we're going to do here in a little bit on the next page. There's not enough room there to do it. But for right now, let's go to the next page and work this. It says translate each of the following verbal phrases into equations and then solve for the number described. All right, the sum of 4 times a number and 6 times a number increased by 11 is 51. So 4 times a number, that would be 4x, the sum of, so we're adding that with 6 times a number, 6x, increased by 11 plus 11 is equals 51. What do you suppose we do first here? Combine like terms. 4 and 6 is 10x plus 11 equals 51. If you can combine like terms first, you should do that. Now we're going to subtract 11 on both sides because we see that addition. That leaves us with 10x equal to 40. And then we get rid of that 10. That's 10 times. The opposite of multiplication is division. So we're going to divide by 10, and we get x equals 4. Okay? All right, look at letter B. 4 less than 3 times a number increased by 6 times the same number is 32.
So 3x.
Okay.
3x minus 4.
Okay.
Plus.
Okay. Very good. Okay, just because the 3x and the 6x are not side by side, we can still combine them together. They're on the same side of the equal sign. And truthfully, we could switch this 6x and this minus 4 because of the commutative property, couldn't we? If we wanted to rewrite it so they were side by side, we could move these as long as we took this negative 4 with the 4, negative with the 4. But we don't need to do that. So 3x and 6x is 9x. Bring down the minus 4 equals 32. Now let's solve that. What would we do first? plus 4 on both sides. So we get 9x equals 36. Next step, divide by 9. So x equals 4. Good. Okay. Letter C. Why don't you take a minute and try that yourself? Okay, who wants to tell me what you came up with for the equation? Okay.
7x minus 4 minus 3x equals 20.
All right, good. Who can tell me the next step? Okay.
Combine the term.
Combine like terms, 7x and a minus 3x.
4x.
4x minus 4 equals 28. Want to keep going, Nolan?
And add 4 to both sides.
Okay.
And then 32.
By the way, guys, I hope you're not just doing work out to the side, and I hope that you're bringing everything down like I'm doing. Please don't try to shortcut it. Okay, I did ask in the beginning for you to write it down the way I'm writing it down. Okay, so you've got a plus 4, and then I want you to draw the line. That means I'm going to bring everything down and kind of start what I have left. Here's my leftover equation, 4x equals 32. Then, Nolan,
Do the opposite of 4x, which is divide by 4.
divide by 4. Very good. And I like that you said do the opposite of 4 times x. And you got?
8. X equals 8.
Good. Very good. Okay, now what I want to do is I want to address the one that we skipped that had the letter E on it. So right there at the bottom, you should have enough room at the bottom of that page we were just working on. We're going to write this out. No. I mean, I guess you could, but what do you suppose we should do first? Okay, so we're going to combine this with this. What does that become? 9 elevenths x. Then 3 and 5 is plus 8 equals 26. You want to try to finish it from there? I would like you to. Well, I would like you to try. Oh, gracious. Let's just see if you're on track. What's the first step that you should do? Okay. So you bring down 9 over 11, x equals 18. Then what?
by 9/11.
Okay, we do divide by 9/11, but how do we write that?
Times 11.
Good, times 11/9. Be careful there, okay? So notice that gives us 99/99, which is just 1, right? So we're left with x equals, now this is 18/1. I would suggest you do some simplifying before you multiply across, because that's big. What can we simplify here?
19.
It's got to be a numerator with a denominator. That becomes a 1 and a 2. And then when you go straight across, you just have 22/1, which is just 22, right? Okay, now, I also noticed that there are problems in your homework that did not show up in your lesson. So I need to add 2. So what I need for you to do, meaning add to your lesson, is on the back of that page we were just working on, it's blank, right? We're going to do some more examples back there. And what I want you to write is this. These type of examples are called variables on both sides, or equations with variables on both sides. So for example, we'll call this letter A. Let's see, 5x plus 4 equals 2x minus 8. Write that down, please. Okay, so this is really important. You cannot take the 2x and the 5x and write 7x. Anybody know why?
Because it's on the other side of the equal.
Thank you. They have to be on the same side of the equal sign for that to happen. When they're on opposite sides, you have to undo them by addition or subtraction. You're not going to try to take the 2 away from the x or the 5 away from the x, okay? Not right now. This is actually the first step you're going to look for, is if there's variables on both sides, you're going to try to eliminate that issue. So I usually look at the smaller one. 2x is smaller than 5x. So it's a positive 2x. So the way we can get rid of the whole positive 2x is by writing minus 2x. But then if we do that, we have to come to the other side of the equal sign and do the same thing. 5x minus 2x is 3x. Bring down this plus 4. Bring down the equal sign. 2x minus 2x is 0. That's what we wanted, right? And then you're left with a negative 8. And now you should be pretty comfortable at what to do now. What do we do next?
Subtract 4.
Subtract 4. So we have 3x equals a negative 8 minus 4 is a negative 12. And then divide by 3.
Negative.
So x equals negative 4. Okay, that's a lot different than if the 5x and the 2x was on the same side of the equal sign. Raise your hand if you have a question, because every year kids want to try to write 7x. You can't do that unless they're on the same side of the equal sign. Okay, let's do another one like that. Call this letter B. Negative 4x plus 2 equals 3x minus 7. Okay, variables are on both sides, so we need to take care of that. We can't just do negative 4x plus 3x. We can't do that. They're on opposite sides. You actually have two options. You can get rid of this negative 4x by adding 4x. To get rid of it there, then you add 4x over to here. Or if you want to get rid of this 3x, what would you do? You'd minus 3x, so then you'd have to come over here and minus 3x. And it really doesn't matter. You'll get the right answer. Your work will look slightly different, but you'll come up with the same answer. I usually try to get rid of any of them that are negatives. So let's get rid of that negative 4x by adding 4x here. In which case we have to go to the other side of the equal sign and add 4x over here and put it underneath the one that has the x. Don't go put it under that minus 7. You can only do that, you can only add it to a term with an x. So we end up with 2 equals what? 7x minus 7. Now, if you don't like that, you can rewrite that as 7x minus 7 equals and put the 2 on this side. It doesn't matter. Gracious. It's being difficult. I don't know. All right, so now, now we need to do what? Add 7 to both sides. So we have 7x equals what? 9. Divide by 7. And 9 divided by 7 isn't lovely, but what could we do? What could we do? Put it into a mixed number. 1 and 2 sevenths. Good. Okay, do you see the difference between the variables on the same side where you can just add them together? Of course, pay attention to their signs. Versus if they're on separate sides. Do you see the difference there? Yes? Okay, I'm going to go ahead and stop this.